Hello and welcome back. Let us try to understand another clustering algorithm called as DBSCAN. DBSCAN basically looks at the continuous regions of high density instances as clusters. We will understand what is continuous regions of high density instances in a moment. The basis for DBSCAN are epsilon neighborhood and core instances. Epsilon neighborhood is very simple. The samples that are epsilon distant from instance are known as epsilon neighborhood. If you take one sample and if you take some radius epsilon, and if there are 10 data points which are within that epsilon radius, right, one data point and its radius, epsilon radius, those 10 data points are called as epsilon neighborhood of the sample you have chosen. Okay, that is one point you need to remember. And the second thing is core instances. An instance with at least min samples in epsilon neighborhood is known as core instances. So if you specify that min samples is equal to 10 and you found a sample which is having 10 samples within the epsilon neighborhood, epsilon radius, then you call that sample, whatever you have chosen, is a core instance. So how core instance and epsilon neighborhood are useful? A cluster in a DBSCAN algorithm, for a DBSCAN algorithm, a cluster means a long sequence of neighboring core instances is considered as cluster. A long sequence of neighboring core instances, I said epsilon radius and 10 min samples. You found one sample with 10 samples within epsilon radius. Again another sample you found within the epsilon radius, 10 samples which are within epsilon radius. Third, and if these core instances are next to each other, you can call that as a cluster. Okay, so epsilon neighborhood means within the epsilon radius whatever data points are present, it is called as epsilon neighborhood. Within epsilon neighborhood, if you have min number of samples we specified as a data scientist, if I specify min samples as 10, if we specify 10 and there are 10 instances within epsilon radius, you say the DBSCAN say that as a core instance. If more core instances are coincide, they are next to each other, neighborhoods, that they are next to each other, then you call that as a cluster, or DBSCAN calls that as a cluster. An anomaly is a core instance which has got no core instances next to it, right? If core instances are overlapping each other or next to each other, then we call it as a cluster. If a core instance is somewhere, right, somewhere out of this total cluster and there are no core instances associated with it or next to it, then we call it as anomaly. Generally anomaly means which is peculiar, right? In a banking sector, if people are defaulting, those are called as anomalies. Generally people repay the loan, right? If somebody is defaulting, that person or that organization is anomaly. And in manufacturing industry, there will be very rarely, 99.9% the production is going to be good, right? Very rarely you get manufacturing defects. So those are called as anomalies. So in a clustering, right, in a clustering problem, you pass 100 records and maybe 95 records got maybe 90 records are actually forming a cluster, and 5 records, rest of the 10 records forming a core instance, but there is no core instance next to it or surrounding it, then we call that as anomaly. So DBSCAN can be used to find to find anomalies also. But in our code example, right, we try to do image segmentation. Let me talk about image segmentation a little bit and then show you the code. So if the problem we have chosen was a textiles problem. In India, we'll have handlooms and power looms. There will be people who will be doing the cloth on handloom machines. So they will have the handloom cloth will have large gaps between each thread and other thread. But power loom generally will not have that much gap. Generally, it is not always, generally. So there is a problem that we need to find out when a picture is taken. We need to find out whether it is a hand loom or a power loom. To figure that out, what we know, the major difference between hand loom and power loom we found was the gap between threads is going to be high in hand loom. The gap between threads are going to be low in power loom. If you look at this, this is a hand loom where you have got lots of gap. You can see the holes in there and stuff like that. So if we can do, if you can highlight those holes and threads in a proper way, right, by doing image segmentation or image processing, some kind of image processing, if you can highlight those gaps and the high colors, you will be able to distinguish between the hand loom and power loom. Maybe we need to build a classification model afterwards, but the first step we need to do is we need to take a picture of hand loom and power loom. We need to process it in such a way that we will identify the the holes and threads like this. Okay, so this can be found on hand looms only. Power loom it will not give, it will give only the color pattern. Whatever the power loom cloth has got color, it will give the same color pattern. That's it. It will not give the the thread, the gaps and thread, this kind of thing. If you look at this picture and this picture, you can identify, you can understand what I'm actually talking about. So we used image segmentation to actually do that. We transformed this image to this image by doing image segmentation. What we did was we passed this to DBSCAN and tried to identify different clusters in there. For each cluster, we took the first record. Right, this image is transformed into 4-column data. Right, when I look at the shape of X, let me see the shape of X here. Right, it actually, the original image is like this. I loaded the image and looked at the dimensions, 645 by 656 by 4. But what I did is I actually transformed it to, I actually reshaped it into a 2-dimensional matrix. 423,120 records. Okay, in India, 4,23,120 we call it as. That many records are there. And 4 columns. I converted the image like that, the pixels like that, because the intention, behind the conversion of this is, I am trying to take each record as a sample, and then I am trying to find the closest samples to each record. Out of these 423,120 records, I am trying to find the closest record to each, or I am actually trying to group records. And when I find groups, right, what I will do is I will take one record from the group and update the whole record. What I am trying to do is, if I see these holes, right, these holes, this hole, this hole, this hole, all these things are kind of one cluster, I will take one color from there and update all records with that. One record from there and update it with the total cluster with that same thing, so that it becomes like this. And we can clearly see that there are this many threads and this kind of a pattern is there. Okay, so let us look at the code and you will understand more. So I have taken this image segmentation will come in deep learning also. We'll talk about this more there also, but let us look at it as a pilot here. So I have taken the image and converted into pixels using imread, right? Matplotlib image imread is the method. Using that, I converted the picture into pixels. It gave me a 3-dimensional matrix because it's a color image. So 645 by 565 by 4 I've got, and then I converted it into a 2-dimensional matrix, and then I applied the DBSCAN algorithm. The DBSCAN object I created here has got epsilon EPS as 0.05, the radius, and min samples is 500. If I find minimum number of samples 500 within 0.05 radius, I will say that as the core instance. If I have more than one core instance associated surrounding one area, then I call it as a cluster. Okay, so I passed the X, I fitted, and then I have got core sample instances are this many. 121,031 records are the core samples. What is core sample? There are 500 minimum samples surrounding those core samples. Okay, within 0.05 radius. What is 0.05? Euclidean distance. Okay, so you take one sample, calculate distance between that sample and all the records in the data set, 423,000 records in the data set, and try to find closest records which are within that 500 radius. If there are 500, then we consider as core instance. If not, we will not, the DBSCAN will not consider it as core instance. Using those core instances which are next to each other, the algorithm formed 19 clusters, and -1 is the anomaly. Wherever you find for any record you find -1 as the cluster, that means that's an anomaly. That's an anomaly means the core instance has got no neighboring core instances close to it. Okay, so the labels is the same thing. Even in k-means clustering, it is labels underscore. Here we have got this many distinct labels, and I wrote a loop where what I am doing here is I am trying to find a labels index. The DBSCAN labels will have all the labels, for 423,120 labels will be there in this DBSCAN. When I say np.argmax of labels is equal to label, what happens is unique labels I am taking, right? It takes -1 and says DBSCAN dot labels underscore is equal to -1. It says that means what? Only records which are belonging to -1, the indexes where you have -1 in the DBSCAN dot labels array will be outputted. Okay, so truths will come and then the indexes will come. When I say argware, right, it actually takes the indexes of all those records where the label is -1. All those places in this DBSCAN labels where the value is -1. The indexes of all those places where the value is -1 it takes. Out of those indexes I am taking the minimum. That means the first index where the label is -1 I took. The first index where the label is -1 I took. Okay, using that index I am actually extracting the row from X. Out of 423,120 records, I am taking the record where the first index where you have got -1, I am taking that record, and I am taking the all records which have got -1 as label and updating with the first record. That means I am changing the color. In that -1 cluster, whichever record belongs to -1 cluster, I took the first record and replaced all the records which have got -1 cluster with the first record. That means whatever color I have for the first record, I am replacing that color with all the other records which have got -1 label. That is called as image segmentation. In image segmentation, you try to assign one color to single cluster. In image segmentation, you try to assign one color to single cluster. Okay, that is for -1. Okay, then in unique clusters next is 0. I am taking the indexes of all the records where the value is 0, and I am taking the index. Argware will give you index, out of which I am taking minimum the first record where the label is 0, the index of the first record where the label is 0, and I am taking that record, the first record where the label is 0, and then I am updating all the records with the label 0 with the first record. First record means the 4 values in this 423,120 records. I am taking that record where I have got label is equal to 0, the first record where label is equal to 0, that will have 4 values. I am taking those 4 values and updating the total data where I have label is equal to 0, like that. Label 1, label 2, label 3 for 19 and maybe 20 clusters here, including the anomalies, 20 clusters. I am taking the first record and replacing all the records which are belonging to the same cluster. -1 first record I took, replaced all -1 records with that record. 0 first record I took, replaced all 0 records with that record. 1 the first record I took, replaced all the records which are belonging to one cluster with that. Like that I did it in a loop. So what happens if you do like that, right? It becomes like the image becomes like this. So this is called as image segmentation. When you do image segmentation, you will understand the pattern at a high level, right? If you look at this image, there are many colors here, but if you look at this, there are only maybe 18 colors, but more evident ones are 1, 2, 3, 4, maybe 4, 5 colors are more evident. When you grayscale this image, right, this will give you some kind of a pattern. For all handlooms or most of the handlooms, you get this pattern. For the power looms, you will not get this pattern. So that is the clue there. So what you need to do is you need to take pictures of handlooms and power looms, apply the DBSCAN, convert them into the whatever the image segmentation you do, then convert into grayscale, build a classification model, and when a new photo of a cloth comes in, you do this processing and pass it to that model, and it will be able to predict whether it is a handloom or power loom. That's the model we were trying to build. So the DBSCAN, I kind of consolidated all those statements here and try to create one block here. There is nothing big here. Whatever we have seen on the top is the same thing. And I tried to run it in a loop with different epsilons and min samples, but I got memory issues. DBSCAN has got memory problems because every time it need to find out core instance, it need to calculate distances between that point and all the other data points, and need to find out whether within that radius the min samples are there or not. So it is a very intensive in calculation. So you can use ball tree and KD tree algorithms here also. Okay, and I try to do this because of memory problems. Some people suggested that we can use an algorithm called as optics, which actually uses DBSCAN as the algorithm. The cluster method is DBSCAN. Optics is another algorithm, other clustering algorithm, which actually uses the clustering method as DBSCAN, algorithm as ball tree, you can specify, and max EPS is the epsilon, whatever the value we have taken there, and min samples is same min samples. So optics actually works more efficiently, and it is more fine-tuned in terms of memory processing. But when I looked at the results, right, DBSCAN gave good results compared to optics. So I'll show you. I've taken these images of cloths, handlooms, and tried to do segmentation using DBSCAN. I found these. So if I open this image, if you look at here, right, it is epsilon is 0.005 and min samples is 400. When I changed the parameter to, it's a hyperparameter tuning. When I changed parameters to 0.005 and 450, it actually neatly does the segmentation. These are the good hyperparameters for this particular cloth, right? You see, I changed it to 500. The segmentation got a little distracted. See that? And if you increase, if I increase to that 600, 700, right, it actually even got distracted. Okay, so 450 is good, and yeah, 450 is good. So 0.005 and 450 are the good hyperparameters. Like that, for other images also, I tried to fine tune the hyperparameters for DBSCAN and found the best hyperparameters, epsilon and min samples, to find out the best segmentation, best segmented image. So the next image I used was this one, right? When I did segmentation, right? This is at 10, 0.005 and 10 as the min samples, right? 15, 20, right? It is getting distracted. You see that? It is getting distracted. So at 0.005 and 10 it worked good. It actually did the segmentation properly. Using this segmentation, right, on the, the what you call it, hand loom, we can actually count threads also. These are all threads. This is a different colored thread and this is different colored thread. Okay, so this is a project we are working on, and I try to show whatever we have done so far. So that's it on DBSCAN and image segmentation. Thank you.